Yes, Lubna, Kutsia,
Yes, ma'am.
any doubt till here?
No, ma'am.
Okay. I think one more student will join. Rimdha will join the class. Let me check if she joined or not. Then we will start the session. Hello, Rimdha. Good evening.
Yes, good evening, ma'am.
Good evening, Rimdha. How are you?
I'm good, ma'am. How are you?
Yeah, I'm good. Okay, so I think you were not in the previous class. So we have discussed many things. Like we have started the methods of preparation of your haloalkenes and haloarenes. Okay, so in that we have discussed the methods of preparation from the alcohols. So there are three methods of preparation from the alcohol. First method is using phosphorus-based reagent. Then second method is using thionyl chloride. And the third method we have discussed about the halo acids. Okay, and the fourth method is from using NaBr in the presence of sulfuric acid. Okay, so I think you will got the recording lectures, or if possible, we will schedule some backup classes.
Okay, ma'am.
Okay, so I'm just, okay, so we have discussed that using sodium bromide, NaBr, in the presence of sulfuric acid will give you a corresponding your halobromide. Okay, your halogen RBr plus NaSO4 as a byproduct. So when alcohols are treated with sodium bromide in the presence of sulfuric acid, my screen has stopped. Just a second. Now, is it visible?
Yes, ma'am.
Okay. Okay, so we just discussed in the previous class that when alcohols are treated with sodium bromide in the presence of sulfuric acid, okay, so here you will get RBr. Okay. Basically, this sodium bromide and sulfuric acid, when you put the sulfuric acid in sodium bromide, okay, so from here, this will form AHBr. Okay, when sodium bromide reacts with sulfuric acid, so it gives you HBr. Now, further, this HBr reacts with this alcohol, corresponding alcohol, to give you this alkyl halide. And this the byproduct you get is sodium hydrogen sulfate, NaHSO4. Now, what's the remarks for this? So, the above method cannot be used for the preparation of aryl halide. Why it is not used for the aryl halides? See, why? Because you know very well, this is a aryl halide, okay? This is a benzene ring, and here the halogen. Now, halogen group, because it has a lone pairs, right? And it is basically a electron donating group, right? It has a lone pair. So it shared its lone pair unbonded electrons to the ring. Okay, and due to that, here between this carbon and the halogen group, there will be a partial double bond form. Okay, यहाँ पे क्या होता है between this carbon and this halogen atom, there will be a partial double bond character due to the resonance, due to the resonance. And this bond is very strong and it is very difficult to break this bond. Okay. So that's why this above method cannot be used for the preparation of your aryl halide. Okay, due to the between the carbon basically, see, just a second. See what happens, because here we are this ROH, we are taking the ROH, right? ROH. So when you are forming the alkyl halide, okay, aryl halide, suppose, okay. So what happens, this is a benzene ring, right? Benzene ring. And when you just take phenol plus NaBr, okay, sodium bromide in the presence of sulfuric acid. Okay, so what happens? The sodium bromide, when it reacts with sulfuric acid, so it will give you HBr. Okay, and this HBr further reacts ring, with this ring. But here, what happens? This is not possible for this HBr to attack this ring. Why? Due to the partial double bond character between this carbon and the oxygen of this hydroxide. Okay, because again, here's a your lone pair. Okay, the oxygen has a lone pair, so it will share its lone pair to the benzene ring, and due to that, here the resonance create. यहाँ पे क्या होता है, resonance create होता है, and due to that resonance, there will be a partial double bond character between this carbon and oxygen bond, and this double bond, CO bond, partial double bond character between the carbon and oxygen is strong. Okay, and it is difficult to break this bond. So that's why this above method cannot be used for the preparation of aryl halide. Okay, because आप अगर aryl halide prepare करोगे तो you will take the phenol. Okay, you will take the phenol, not your ROH. You will not take this ROH. Okay, your aliphatic uh, alcohol. Okay, you will take the aromatic alcohol, and the aromatic alcohol is phenol. Got my point?
Yes,
Yes,
ma'am.
ma'am.
Any doubt in this?
No, ma'am.
And just remember, this is very important. So the reactivity is very important. So the benzyl alcohol is more reactive than your allyl, then your 3 degree, then your 2 degree alcohol, then primary, then your methanol. Okay, just remember this order. And you know very well what's the difference between allyl, benzyl, and any alcohol, because we have discussed in the very first class. Okay, what is benzyl alcohol? So here the halogen group is first attached to sp3 hybridized carbon, and this sp3 hybridized carbon is attached to the benzene. This is your benzyl. And what is allyl? Yes, Putsia, what is allyl halide?
Yes, ma'am.
What is
When
allyl?
when sp3 carbon atom is joined to a carbon atom, it is joined to an sp2 carbon atom which has double bond, and the sp3 carbon atom is also attached to halide.
So halogen is first attached to the sp3 hybridized carbon atom, and this sp3 hybridized carbon atom is further attached to sp2, means carbon carbon double bond. So that's the allyl. Okay, then tertiary. Right? Okay, so what is tertiary? Tertiary alcohol. So tertiary alcohol, suppose this is your OH group, and this OH group is attached to this carbon, and this carbon is further attached to three other groups. Okay, this carbon is further attached to three other groups. So this is a tertiary ester. This is your tertiary alcohol. Okay, after that, what is secondary? So secondary means this OH group. Sorry, because we are talking just a second. Yeah, because we are talking about the ROH group, right? So we will take here, you will add OH group, right? Because we are talking about the rate of reaction for haloacids of your alcohol. Okay, alcohol की बात कर रहे हैं, तो you will put OH. Okay, so when the hydroxyl group is further attached to your sp3 hybridized carbon, and this sp3 hybridized carbon is attached to sp2, then it is your benzyl. Okay, And when what is allying? So OH group is first attached to sp3, then sp3. Okay. Similarly, your 3 degree. This is your 3 degree. Similarly, what is secondary? So secondary is this carbon, and this carbon is further attached to two groups, CH3 groups, and here other CH3. Okay. And you know very well what is primary. So primary CH3, because this is CH2 and OH. Okay. And methanol. Methanol means CH3OH. Okay. Simplest, your simplest alcohol. Got my point? So just remember this rate of reactivity towards the haloacids. Okay. Next one. Now here's a question. Write down the question. Why H2SO4? Why is H2SO4 sulfuric acid not used during reaction of ROH alcohol with potassium iodide? Now, okay, this question is important. Now here's a question. When you suppose मैं reaction लिखती हूँ. Suppose we do the reaction ROH, okay, alcohol plus your potassium iodide, okay, plus your H2SO4, H2SO4, okay. So what happens here? What happens here? We will not use this H2SO4 with AI. What's the reason? Now see, because this sulfuric acid is a strong oxidizing agent. Okay, it's a good oxidizing agent. So ये क्या करेगा? Because you know very well what is basically, just a second, it's not, okay, just correct it here. बच्चों, just correct it over here because we are talking about the haloacids. Okay, so HI, just write it down, HI. Now it's not potassium iodide, it's a hydrogen iodide. Okay, just like your HCl, HBr. Okay, so it's HI. So what happens? H2SO4, we can't take the H2SO4 sulfuric acid with HI as a haloacid. See, HI. Now, what's the reason? Because this sulfuric acid is a strong oxidizing agent. So it will oxidize this HI. ये क्या करेगा? H2SO4. In the presence of H2SO4, this HI will oxidize to your I. Okay, it will oxidize to your I. Okay, you can say I2. Okay, and here you can balance 2HI and I. And what we need for the reaction, we need haloacids. Okay, so when you use a strong oxidizing agent, so oxidizing agent will oxidize this HI. Okay, and who will tell me what is oxidation and what is reduction? What's the difference between oxidation and reduction? Yes, Lubna, what is oxidation?
Addition of oxygen.
Yes, but here what's happening over here? HI is being converted into I2. So what happens over here? The removal of hydrogen is also oxidation, right?
Yes, ma'am.
Yes. So here the removal of hydrogen is happening, right? So it's again a high oxidation. So when you use HI, okay, with sulfuric acid, okay, or any oxidizing agent, so it will oxidize this HI to I2. Okay, and this I2 will not react with your alcohol to give you a corresponding alkyl halide. So that's why we don't use the sulfuric acid along with the HI. Okay, why? What's the reason? Because this will oxidize this HI to I2, and I2 will not react with your alcohol to give a corresponding alkyl halide. Okay, so जो हमें चाहिए, we will not get that. So that's the reason why we can't use sulfuric acid with your alcohol or your halogen acid, which is HI. Okay, got my point, everyone? Utsia, Lubna, Limda.
Yes,
Yes.
ma'am.
Okay, now you can write down. Write down as sulfuric acid H2SO4 is a strong oxidizing agent. So it converts HI to I, which does not, which doesn't react with alcohol. Doesn't react with alcohol. Okay. Now the question is, so which acid we can use along with the HI? Okay. So which acid? So we use the phosphoric acid instead of sulfuric acid. Okay. So write down instead of sulfuric acid H2SO4, we use mild oxidizing agent. Mild oxidizing agent like H3PO4. Okay, phosphorus acid, which provide HI. Okay, now because this is a mild oxidizing agent, so it will not reduce, it will not oxidize this HI to I. Okay, and you will get the corresponding HI. Now HI will be as it is, and this HI will react in the presence of your H3PO4. Okay, to react with alcohol to give you a corresponding alkyl halide. So instead of sulfuric acid, we use a mild oxidizing agent. And this H3PO4 is a mild oxidizing agent. Okay, so we instead of a strong oxidizing agent, we just use mild oxidizing agent, just like your phosphorus. Okay, so which will provide you HI and does not convert. Yes, Rinda?
No, ma'am, it's a mistake.
Okay, I thought you have a doubt. So
No,
instead of
ma'am.
sulfuric acid, we use mild oxidizing agent H3PO4, which provide HI. Okay, and it does not convert it to I. Yeah, and you can also write down the correct reaction. So ROH, when you treat it with HI, HI plus H3PO4. Now you will take H3PO4 instead of your strong oxidizing agent, which is sulfuric acid. Now you will take this. Okay. Now what happens here? What happens over here? Now you will get a corresponding RI. Okay. Because you are using the your hydrogen iodide, so you will get the iodide product. Okay. Here what happens is hydroxyl group, OH group is replaced by your iodine group. Okay. And you will get a corresponding RI as a product. Got my point?
Yes,
Yes,
ma'am.
ma'am.
Okay, please write it down. Can everyone? Okay, so that was the first preparative method, okay, from the alcohol. Okay, so we have seen that from the alcohol, like when you take your ROH, okay, alcohol group, so there are various ways by which we can get a corresponding alkyl halide by alcohol, okay, by changing the reactants, just, sorry, reagents, okay. So ROH, here it is. When you treat it with PCl3, what you will get? Yes, Lubna, what will be the product when alcohol will be treated with PCl3?
RCl.
Good. Yes. Second, what will be the product when the alcohol is treated with your, suppose, HX? Any halo acids, HX. Yes, Putsia, what will be the product over here?
Rex.
Yes, RX, right? RX. Okay, so OH will be replaced by this halogen atom. Okay, halogen could be anything, your chlorine, bromine, iodine. Okay, third, we have discussed with in the presence of your HCl plus ZnCl2. Okay. Yes, Lubna, tell me which reagent it is. What is the common name of this reagent?
Hydrochloric acid.
Yeah, it's a hydrochloric acid. The combination of these two, HCl plus ZnCl2. So what we call it as? Which reagent? And in which test we use this combination? HCl along with ZnCl2. We discussed in the previous class.
Oh, yes, ma'am. Lucas reagent.
Yes, it's a Lucas reagent. Okay. So what will be the product over here?
RCl plus H2O.
Okay, very good. When you treat it with thionyl chloride, yes, Rimda, do you know when alcohol is treated with thionyl chloride, this is SOCl2. So what will be the product?
RCl?
Yes. Okay, so OH is hydroxyl group is replaced by the chlorine group and you will get again RC. Okay, and there are other, okay, other reactions also. So you can just revise these questions. This is very important. And this is very, very important. Okay, so this HCl plus anhydrous ZnCl2 is known as Lucas reagent. And what's the use of this Lucas test and Lucas reagent? So it is used for the distinction between primary, secondary, and tertiary alcohol. Okay, so this is very important. So just learn that. Okay, now the second, we have done this. Okay, first alcohol. Now the second one, write down. Second method of preparation is from hydrocarbon, hydrocarbons. Okay, so from hydrocarbons, we will see different methods of preparation. Like when you take the alkane, when you take the your alkene, okay, and different with different reagents, so it will give you a corresponding alkyl halide. Okay, first point in the hydrocarbon part, from the hydrocarbon, write down the first method, free radical mechanism. Free radical halogenation, halogenation of alkenes. Free radical halogenation of alkene. Okay, so general reaction is, so what is this reaction? Free radical halogenation of alkenes. So in this reaction, there will be a formation of radical, free radical. Okay, basically the halogen, when you take the halogen group, so halogen just break down and it just form the free radical. and those free radical will react with the corresponding reagent, okay, reactant, and it will give you a corresponding product. Just remember, in this method of preparation, you will get a mixture of your halides, a mixture of halides. That's why this method of preparation is not preferred. Okay, because you will get a mixture of halide, mixture of primary, secondary, tertiary, okay, quaternary, this type of halide. Got my point?
Yes.
Okay. So see, was the general reaction. So when RH, okay, this is a corresponding hydrocarbon, plus when you take X2, okay, halogen, okay, X2, and in the presence of any one of them, HELPR, these reagent. Now, what is helper? Just remember the shortcut, helper. So what is helper? Write it down, HELPR. Okay. So H refers for heat. If you take heat, the second E for electricity, L for your light. Okay, light means your your UV light. Okay, UV light. So you can see this symbol H nu. Okay, H nu, photons. Now P for the peroxide. When you use this reagent, okay, along with this X2, so it will also follow this free radical halogenation. Okay, and R for the radical. R for the radical. So this free radical halogenation of alkane can proceed, okay, with this, with these reagent. Okay, any one of these reagent is if present on the arrow. If you see above the arrow, like your H nu, okay, or peroxide or radical, any radical. So just remember, this is the method. This is a free radical halogenation of alkane. Okay, so just remember the shortcut HELP. Okay, H for heat, electricity, light, peroxide, and radical. Okay, peroxide basically we just take it as H2O2 hydrogen peroxide, H2O2. Okay, so when you, the reagent is this helper and RH hydrocarbon plus your, when you treat it with the halogen X2. So in this process you will get RX plus H. Okay, now see, because there are two X, right? So one X will be attached, one halogen atom will be attached to this R group, alkyl group, okay, and one halogen group will attach to this, okay, and you basically this bond will break and you will get these two products. RX, okay, RX is your alkyl halide plus your HX, okay. If you are taking Cl2 over here. Okay, so suppose this is your RH plus, okay, any halogen plus your Cl2, okay, in the presence of suppose Hv, any one of them helper between any. Okay, so you will get, because you are taking the chlorine over here, two chlorines are there, right? So one chlorine will attach to this R group and one chlorine will attach to this H group, and it will give you RCl, okay, plus your HCl. Got my point?
Yes, ma'am.
Now suppose if we take CH4, methane. So methane is a simple hydrocarbon, right? CH4, methane plus Br2, halogen, right? In the presence of again H nu, okay? So what will be the product? So what will happen over here, right? First, first this is a Br2, right? So this is a, suppose you can write this CH3, okay, alkyl group and one hydrogen, okay? So one bromine and second bromine. One bromine will attach here and second bromine will attach over here. So you will get CH3Br plus your HBr, okay? And see, it is not necessary to write on the byproduct, okay? You can only write on the major product. Okay, so you will get, so I'm not writing here the byproduct, I'm just writing the CH3Br. Now, because this Br2 again this Br2, because it is in excess, right? So again this Br2 will react to this CH3Br, and again you will get, again what will happen, one hydrogen from here, from this alkyl group will goes to one bromine. Okay, see how you can show this, basically. So CH2, right? And here you can write H, okay, and then Br, okay, this type. And this, now what will happen, this, just a sec. Here I am writing the bromine, okay. So this is one bromine, this is the second bromine. One bromine will goes over here, right? And the second bromine will attach to this hydrogen. Now what will be the product now? CH2Br plus this Hb. Okay, what you're supposed to do, from the alkyl group, just remove one hydrogen, okay, and attached to the one bromine atom. Okay, and one bromine atom you will attach over here. Okay, so what you will get? You will get CH2. Okay, because you are removing the one hydrogen from here, and Br2. Just add one bromine. Okay, add one bromine to this product and remove one hydrogen. So you will get CH2Br. Got my point?
Yes, ma'am.
Yes, ma'am.
Okay. Again, again, तब तक ये रिएक्शन चलता रहेगा जब तक Br2 is available. Okay, whenever the Br2 is being fully consumed in the reaction, then the reaction will stop. Then the reaction will stop. And in this, as I told you, in this free radical halogenation of alkane, you will get a mixture of product. Mixture of product. Okay. So this CH2Br2, again this CH2Br2 will react with Br2. Okay. And here what will happen? Now tell me what will be the product now? Just remove one hydrogen from this alkyl group, okay, and add one bromine over here. What will be the product? CHBr3, right? CHBr3. Again, okay, again this bromine, okay, Br2 will come, and now what will happen? One hydrogen is left. तब तक reaction होगा when the hydrogen is there, okay, in the alkyl group. Okay, if hydrogen is fully consumed and this bromine is fully consumed in this reaction, then the reaction will stop and you will get the mixture of product. Okay, now just remove this hydrogen. So what you will get? You will get CBr4. Okay, now you can see, you will get this CH3Br, CH2Br, CHBr3, and CBr4. Okay, this is your primary, right? This is your secondary, right? This is your tertiary, and this is your quaternary. So basically, in this free radical halogenation of alkane, you just get a mixture of mono and polyhaloalkane. Mono, this is your mono haloalkane, and this is a poly. Okay, more than, basically secondary, tertiary, and quaternary, so you can call it as a poly, okay, haloalkanes. Okay, now one point, write it down. Since free radical halogenation gives a mixture of mono and polyhaloalkanes, haloalkanes, which are difficult to separate. To separate. Okay, so hence this method of preparation is not preferred. Or you can write it is not a preferred method of preparation of haloalkenes. Okay. Now the purpose of this reaction is basically, now the question here is how we can get a monohaloalkane as a major product. Okay, as a major product, because all these are mixtures. Okay, so how you will get a monohalogen, because we only get this product. Okay, we only get a monohalogen product. So write down, to get a monohaloalkane as a major product, alkene is taken in axis. Taken in axis. Okay. Now here's a question. Right. See, because in the first here, as I told you, because we were taking this is free radical halogenation of alkane. In this reaction, we just take the halogen group in excess. In excess, right? So हम क्या कर रहे थे? This halogen Br2 we were taken in excess. So due to that, we just get the mixtures of your monohaloalkenes and your polyhaloalkenes, your primary, secondary, tertiary, and quaternary. Okay, haloalkenes. But if we have to get a monohaloalkene as a major product, so we just take the alkene, the hydrocarbon chain in excess. Okay, the main, just remember this major product, if we just get the monohaloalkane as a major product, so alkene is taken in excess, not the halogen atom. Okay, not the halogen atom. For example, if we take CH3, okay, ethane, C2H6, ethane, plus when you react it with Br2, what happens? What happens? Because this is a 2Br, again, same mechanism. Okay, one bromine will goes to this. Okay, and second bromine will goes to this. Okay, and this bond will be break, and you will get these two CH3, right? So basically, just a second, just simple remember. Okay, now in this method, what you are supposed to do? Okay, you are not supposed to do this thing, the same thing. What you're supposed to do is CH3 and CH3, right? This is your CH3 and CH3. So you can write it as CH3, CH2, and H. So one, you have to just remove the HBr. Okay, HBr. So first this bromine will attach, because this is a symmetrical type of alkene, right? CH3 group over here and CH3 group. This is a symmetrical. So in the symmetrical type of alkene, so it is very easy to write down the product. This bromine, first आपने क्या करना है? This bromine को attach करा देना इससे. Just remove one hydrogen from here and just attach the bromine here. So CH3, CH2, and Br. First product. Okay. So this, suppose this is the first carbon or this is the second carbon. So we just attach the bromine to the first carbon. Okay. Now what about the other bromine? So other bromine we will attach here. Okay. We will attach here on the second carbon position. Just remove one hydrogen and attach the bromine over here. So you will get Br, CH2 and CH3. Br. Okay. So what is this? This is your bromoethane. You will get a bromoethane. Clear?
Ma'am,
Is
can
this
you
reaction?
explain?
Yeah. Okay. So see, Lubna, because this is a symmetrical type of alkane, right? CH3 group over here and CH3 group over here. What you are supposed to do, this is CH3, CH3. Suppose this is the first carbon, second carbon. Okay, there are two bromine. Okay, Br2. So first, what you're supposed to do, just add one bromine here, okay, and the second bromine here. So basically, you will get two products. First product will be CH3, where you are just adding the bromine to first carbon, first carbon. So you will get CH3, CH2, and Br. Is it clear? First
Yes,
product
ma'am.
plus plus second bromine, because second two bromines are there, Br, okay, and other Br. So second bromine will attach on the second carbon. Second carbon पे attach करा देना. Now, if you attach this bromine to the second carbon, this carbon, so you will get Br, okay. And what is this? This CH2. You will write CH2 and CH3. Okay, so you will get two symmetrical type of product. Basically, if you write down the name of these two, so both are same. Okay, so you can write 2 moles of your bromoethane. 2 moles of bromoethane you will get. So these two are bromoethane. Now it is clear.
Yes, ma'am.
And Kutsi and Rimda,
Yes, ma'am, it's clear.
Yes, ma'am.
okay, suppose if we take, so this is all about the symmetrical type. So you can see, one more thing, symmetrical type of alkene will give the same type of molecule. Okay, so we will just assume it as a one, only one. Okay, basically this, if you write down the name, so both are bromoethane. Okay, bromoethane. They're not different. So we will consider it as a one product. Okay, so just remember symmetrical type of carbon, okay, or symmetrical, the carbon which has the same number of hydrogen will give the same product, will give the same product. For example, if it is CH3, CH2, CH3 plus Br. Now the question is, what is the product? How you will write the product over here? Very simple. Just remember this trick. Okay. See, if the symmetrical, this is the symmetrical type, this carbon and this carbon is symmetrical. Yes or no? It has a CH3, this is a CH3, and again this is a CH3. So this is a symmetrical type. Yes?
Yes, ma'am.
Yes, ma'am.
And this is different. This second carbon is different. This is CH2. This is CH2. Okay, I'm showing it by a different pen. Now, these two same carbon, CH3 and CH3, will give you a same product. So you will write only one time. Okay, you can attach the bromine over here, okay, or here. दोनों में से कहीं पे भी आप attach कर सकते हो. You will get the same product. Okay, it's all up to you. Now, I'm just attaching this bromine here on the first carbon. So you will get CH3, CH2, okay, CH2 and Br. First product is clear.
Yes, ma'am.
Okay. Okay, so basically this again, if you attach this bromine over here, so you will get the same product. Okay, Br, CH2, CH3, CH3, right? For the symmetrical, okay, so just remember the number of monohalo product of your free radical mechanism is equals to the number of different hydrogen in alkene. So how many different hydrogen in this alkene? How many different? Two, only two hydrogens are there, right? One is this CH3, right? Three hydrogen, ये क्या है? Three hydrogens, and here the two hydrogens. So two different hydrogens are there, so you will get a two different product. Okay, so for the symmetrical one, you have to write only one product, not both the product. Okay, because in the first example, you can see this is a symmetrical one, CH3, CH3. You got the same product, right? The name of the product is bromoethane. Okay, so you will write only one time. Okay, if you attach the bromine on the second this carbon, this is different, right? CH2 is different. This is not a symmetrical. So you will get another. So you have to attach this bromine over here. So what will be the product? CH3, right? It's CH and here the bromine and CH. 1, 2, 3. So these two are the products of this reaction. Is it clear?
Yes, ma'am.
Yeah, so just remember the trick for the symmetrical type of carbon. Okay, or you can write if the hydrogens are same. If the hydrogen number of hydrogen is same to that carbon, then it will give you a same product. So you have to write only one product. Okay, you will not write two products for both the carbon. You will write for the symmetrical one, it will give only one product. Got my point? Yes, Lubna, do you have any question?
No, ma'am.
Okay. One more point you can write. Number of mono halo product. Mono halo products of it's a free radical halogenation. Free radical halogenation is equals to the number of different hydrogen in alkane. Okay, just remember this trick, so it will be very useful for you to write down the product. Number of monohalogen product is always equals to the number of different hydrogen in alkane. Okay, let's do some question based on this, so it will be more clear. First question. Second. And yeah, just remember all these are in the presence of on the presence of light or any one of them. Okay, helper. You have to write on the products. Second one. Quickly do it. First, we have to check which hydrogen is symmetrical, or which carbon you can say which carbon has same number of hydrogen. So they will give you only one product. You will write only one product for that. One. So these are symmetrical. CH3, CH3, right? So this will give you only one product. So you can attach bromine either on the first position or on the third position. And the second carbon will this have two hydrogen. This have two hydrogen, so this will give you another product. Yes, Rimda, so how many products will it give? How many products in the first question?
Yes, ma'am.
So in the first reaction, how many products will be there? See, the number of product is equals to the number of different hydrogen in alkane. Okay, see, this is CH3, CH3. Okay, this terminal one. Okay, this is your CH3, right? Again, this is a CH3, and the second carbon is your CH2. So, how many different carbons are there? Yes, Rimda, tell me how many different. You can say hydrogen, right? How many different hydrogens are there in this alkane?
Ma'am, there's two.
Yes, it's two. See, CH3 and this CH3, this is symmetrical one. Okay, this is the
Yes.
same. So it will give you only one product. either you can attach this bromine to this first carbon or on the third carbon. It will give you the same product. Okay, you can write it down. If you just attach the bromine to the first carbon, right, and just try to write down the name, IUPAC name of this. Then attach the bromine on the third carbon, and after that, just try to write down the IUPAC name. You will get the same name. Okay, so for the symmetrical type of your hydrogen, it will give you only one product. Okay, so basically, how many different hydrogens are there? So this one is same. Okay, so this will count as a one. Okay, this CH3 and CH3 को आप two count नहीं करोगे, one CH3 and one. This will count as a only one. Okay, and this CH2 it will count as a two. So it will give you two products. First, you have to attach this bromine on the first or either first or on the third position. It is up to you. So 1, 2, 1, 2, 3 carbon, 1, 2, 3 carbon, and here the bromine. Okay, I'm attaching the bromine on the first carbon, so you will get this product. Plus, when you attach the bromine on the second carbon, so what will be the product? So this will. So these two are the products. Lubna, Kutsia, Rimba, clear?
Yes, ma'am.
Yes, ma'am.
Yeah, so first step, just check how many different hydrogens are there in that alkene. Okay, and if it is symmetrical, same hydrogen atom will be taken as one. You can attach, you can just treat it like a one. Okay, आप उसे एक ही तरह treat करोगे, and you can either attach the bromine to the either on the first position or on the other position. Okay, so it will give you the same product, first one product. And the other different hydrogen, see this is a different hydrogen, so it will give you another product. बस आपको halogen का attachment कराना है. Just keep this in mind. Second, first you have to count how many different hydrogens are there. So this terminal one, this is your CH3, CH3, it will count as a 1. Okay, it will count as a 1. Now these two, this CH2, okay, and this is again CH2, these will count as a, okay, that's why मैंने एक same color से show किया है यहाँ. This red one, it shows the same hydrogen, and these blue one, it shows the same hydrogen. Okay, so number of monohalogen, if I ask you how many monohalogen product will be formed in this reaction? Yes, Kosia, tell me, second one, how many product will be formed in this reaction?
Four.
4?
Two.
Yes, 2, very good. Okay, so these red color, this terminal one, it will give you one product, and this one, middle one, it will give you the second product. Okay, and you can attach either, it's up to you. You can attach the bromine to on the second position or third position. Okay, it's up to you. And okay, so I'm just writing the product over 1, 2, 3, 4 carbon. Okay, and the one bromine. Plus, second will be, okay, if I attach the bromine on this position. Okay, so these are the two products. What about the third one? Third question. Okay, you have to check the symmetry. Okay, see the symmetry. If you just see these two carbon will give a one product. Okay, these two, 1, 2, these two carbon will give you another product, second product, and this middle carbon will give you another product. Okay, you will not consider these three carbon like second, third, and fifth, second, third, and fourth carbon like a one product. Okay, you can attach the bromine. You will get, see, if you attach this, you know very well this first position, this red color, this terminal end. The terminal end will be considered as a one product. Okay, so you will get, this is a symmetrical, so you will get a this product. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbon, and here the bromine is attached. Okay, this product is for this red color, which I have mentioned it here over here. Red color से जो मैंने जो लिया. See this one, this carbon. Now, second product. So this one, the second carbon, okay, and this is suppose this is the first carbon, second carbon, third, fourth, and fifth carbon. So second carbon and fourth carbon will give you a same product, okay. So you can attach the bromine either on second position or on the fourth position, okay. You will get the same product. Okay, आप attach करके देख भी सकते हो. Just write down the IUPAC name. You will get to know why it is same. Plus third one. Okay, so third one, when you attach the bromine on the third position, you will get this. Okay, so this is different product. This is different product. Okay, 1, 2, 3, 3 bromo. Okay, and it is your pentane, 3 bromo pentane. So in the third case, you will get a 3 mono haloalkane. Got my point?
Yes, ma'am.
Yes, ma'am.
Everyone, Linda?
Yes, ma'am.
Okay, any doubt?
No, ma'am.
Okay, so here's a question, another question, write it down and tell me the answer. C5H12. C5H12. It's a molecular formula of, it gives only one monochloroproduct on photochlorination. Photochlorination. Identify the compound. Identify the compound. C5H12. Okay, first draw all the isomers of C5H12. Okay, and just check which isomer will give you only one monochloro product, only one product. And you know very well how to check the product, how many product it will give you. So just like that. Okay, so the symmetrical one will give you the one product. Okay, and basically it will depend on the number of monohalo product. See this point. Just keep this point in your mind, and after that just do that question. So it depends on the number of different hydrogen in the alkane. Solve this question. C5H12 gives only one monochloro product on photochlorination. You have to identify the product. First step, just draw all the isomers of C5H12. And see, it's very easy. See, C5H12. Okay, so means 5 carbon. Okay, and basically it's an alkane. 1, 2, 3, 4, 5. Okay, so this is a normal straight chain of the C5H12. Okay, now what you are supposed to do, you have to just draw the positional isomers. Okay, you can draw the positional or reduce the chain size. Okay, you can draw the chain isomers also. So 1, 2, 3, 4, 5. Okay, so it's a C5H12, right? or basically it's a normal pentane. Okay. Now you have to reduce the size, so you have to draw the 1, 2, 3, 4 carbon chain, and you will treat one carbon as a substituent, as a branching. आप एक carbon को कैसे use करोगे? As a branching. So this is another isomer. Now if you just change the position of this methyl group, CH3 group, so you will get the same. See, if you change the position, suppose this is the second position, and if you are just shifting this methyl group on the third position, again it will be same. See, these two structures are same. Okay, because when you write the IUPAC name, so it is 1, 2, right? 2 methyl, or what is this? This is butane. And again, when you write down this IUPAC name, so it is first, second 2 methyl butane. Okay, so you cannot draw this, you cannot shift the methyl group on the third position. Now, so two isomers we have drawn. What about the third one? So you can reduce the one carbon chain. You can draw 1, 2, 3 carbon chain. आपने draw कर लिया as a parent chain, and because there it is C5H12, so 2 carbon is again remaining. So you will just use it as a branching. Okay, you will use that. So these 3 isomers are for the C5H12. Isomers हमने कैसे draw किया? Is it clear? Lubna, Kutsia and Rimdha.
Yes, ma'am.
Now tell me this first one. See, suppose this is your A, this is your B, and this is your C isomer. Now, Lubna, tell me for the first one, how many products it will give on the photochlorination?
Ma'am, 3.
Yes, very good. It will give you 3 products. Okay, so this is symmetrical, right? So this will give you 1 product, right? These 2 will give you another product, and the center one, this one will give you another product. So 3 products. Okay, Kutsia, next one. Tell me how many products it will give. The B1.
Yes, ma'am.
Yes.
1.
Only 1 product. For this B isomer. Okay, see. See, this carbon, and this carbon will give a same product, right? Only 1 product. It will be counted. Next, this will give you another. Okay, this will give you another product. Okay, so second 2 product. This will give you another product. This one. Okay, this is different hydrogen group. And for this carbon, this will give you another. This one. This one. Right. So these red one, I'm just let me check. 1, 2, 3, 4. Okay, मैंने number show कर दिया. Now see, the first carbon, this first position, and the second fourth one. First and fourth one will give you a single product. Okay, because these are symmetrical type. Okay, because these are same type, you can say. Okay. Second, this third one will give you another product. Okay, ये किसी की तरह symmetrical नहीं है. It is just individual one. So it will give you the second product. Okay. Now this the second carbon, which I have shown it blue color, right? So it will give you another product, right? 3 product. And this substituent, this methyl group, CH3 group over here, which is acting like a substituent over here. So this will give you another product. Okay. So now tell me how many products. So it will give you 4 products. Will give you 4 products. Clear?
Yes, ma'am.
Yeah. So just 1 is equals to 4. Okay. 3. Okay. 1 and 4 will give you same product. The third one will give you single product, second carbon, and the fifth carbon. So that's why 4 products. Rinda, tell me the third one, third isomers. How many products it will give?
Ma'am, is it 1?
Yes, very good. Okay, so it will give you only one product. Why it will give you one product? See, this is your carbon. Okay, and this carbon has no hydrogen. This carbon has no hydrogen. Okay, so basically it will not give any product, this carbon. Okay, now this CH3, 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 and CH3. Okay, all substituents are same. CH3, 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 CH3. Okay, so you will count only one product. Okay, you will count them as a, and for this it will give you only one product. Okay, now will be the answer? C5H12 gives only one monochloro product on photochlorination. Identify the compound. Okay, so obviously this will be your compound. Now see the reaction. What will be the reaction over here? It will be the reaction over here. So this is your neopentane. Okay, this is structure. This is your carbon, right? This carbon, and this carbon is attached to four methyl groups: CH3, CH3. Okay, here CH3 and CH. Okay, so this is a neopentane. Neopentane. Okay, just do the chlorination. Cl2 in the presence of sunlight. Okay, in the presence of sunlight, because we are doing the photochlorination. Photo means light, right? In the presence of light, and what does light means? H nu. Okay, so Cl2 plus H nu. So it will give you which products? Obviously, this for this CH3, 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 CH3. You will treat them as a single one. Okay, so you can attach this chlorine to any one of the carbon, to any one of this methyl group. Okay, the product, and you will write this CH3 over here, CH3 over here, and here this is become CH2 and C. So that's the product on the chlorination. Okay, photochlorination of neopentane will give you a monohalogenated or monochloro product. Monochloro product. Only one monochloro. So that's your answer. Okay, in your exam, that's how the question will come, and that's how you will write in the exam. Is it clear? Any doubt? Now you can ask. Just clear your doubt. कोई भी doubt नहीं रहनी चाहिए, because this question is very very important. Rimba, Kutsia, Lubna, bachcho, any doubt?
No,
No,
ma'am.
No, ma'am.
Okay. Now let's understand the mechanism. Let's understand the mechanism. How this reaction occurs step by step, we will see. So basically, write down the mechanism of the Friedel-Crafts, sorry, what I'm saying, free radical halogenation reaction of alkene. Mechanism. Okay, so basically this free radical halogenation of alkene, okay, it occurs via three steps. Okay, it's in this reaction, three steps are included. First step is chain initiation. Chain initiation, after that chain propagation, and after that chain termination. Okay, because if you don't terminate the chain, the reaction will proceed. Reaction hota rahega, reaction won't stop. Okay, so at last we have to terminate the chain to stop the reaction. Okay, it's because it's a chain reaction, so it will occurs in a cycle. It won't stop. Okay, so that's why in the last step you have to terminate the chain. So basically this reaction, suppose this is your reaction CH3, CH2, CH2, CH3. We take this. Okay, propane plus you do the bromination Br2 in the presence of light, UV light. Okay, so what will be the product? So it will give you two products, right? So this CH3 will give you a single product, and this CH2 will give you another product. So two products. Now the question is how this product came. So you will see it by using mechanism. These two products. Okay. Now a step. First step is chain initiation. Chain initiation. Now, what is chain initiation? So chain initiation, just a second. Okay, so what happens over here in the chain initiation reaction? This halogen, this is Br2. Okay, this Br2, it breaks into a radical. Okay, ये क्या करता है? Radical form कर लेता है and it will give you O Br plus Br, two radicals. Okay, so now let me show it here. What happens over here in the first step, chain initiation, chain starting. So how this chain starts? So chain initiate कैसे होता है? This B bromine, this is Br2, right? Now this you know very well. This bond has, okay, this is this Br2, the bond between this B bromine and bromine. Okay, it has a the bond basically is formed by the sharing of electrons, right? So this bromine shares one electron and this bromine shares one electron. Okay, and here the bond form. So what happens in the chain reaction, chain initiation? This bond will break. Okay, this electron, it will goes on this bromine and this electron, it will goes on this bromine. And in the presence of, it occurs in the presence of light. Okay, UV light. And it will give you your free radical. Okay, so Br and free radical को हम कैसे show करते हैं? Just a dot on the bromine. Just a dot on this. This is a free radical. Okay, free bromine radical. First step. First step is clear. How does chain initiation occur?
Yes, ma'am.
Lucy and Rinda?
Yes, ma'am.
Okay. So you have to just break the bond. Okay, one electron will goes on this bromine and one electron goes on this bromine and it will form a radical, free radical. Now this free radical, this bromine will react with the reactant. This. Okay, this is a reactant CH3, CH2, CH3. This alkane के साथ react करेगा. So second step is first step is chain initiation. Okay, second step is chain propagation. Chain propagation. Okay, so chain propagation is basically the, you can say, multiplication of the chain. Okay, chain multiply hota hai, and how does chain multiply? So just see over here. This is your, just a second. Yeah. So we just take the propane, right? CH3, CH, okay, CH2 and CH2, right? So this is CH3, right? Now what happens over here? What happens over here? Suppose this, I'm just showing it like this CH2 को मैं ऐसे show कर रही हूँ, this CH and one hydrogen over here. Okay, because this hydrogen will be involved in the chain propagation. Okay, with the bromine. Now this CH2, okay, because this has a three hydrogens, CH3, and I'm showing this, it is as CH2 and one hydrogen like this. Okay, first reaction, first C, if because you are treating it with Br, the bromine ion, sorry, not free radical, not ion I will use, the bromine free radical will come, okay, will come here, suppose. Okay, it has a radical. Okay, and again this has a bond, this hydrogen and this chlorine. Okay, because they are bond formation ka, so obviously here the electron will be shared between the carbon and hydrogen. Now what happens? This bromine has a free radical. Okay, it share its free radical. Okay, to this hydrogen and hydrogen share its free radical, and you have to show like this. आपको ऐसे show करना है कि यहाँ पे sharing हो रही है. Right? Between the hydrogen and the bromine free radical, there will be a sharing. Okay, and what happens over here? what happens here in this case, when the bromine radical comes and it reacts with this hydrogen, okay, first carbon, this terminal carbon hydrogen, okay. So here the product will be your CH3, CH2 as it is, and here CH2, and it will form a carbon free radical. ओके बेसिकली ये इसके हाइड्रोजन क्या होगा, इसके साथ Br के साथ बॉन्ड फॉर्मेशन कर लेगा, ओके, एंड फ्रॉम हियर द हाइड्रोजन विल बी रिमूव and HBr as the HBr, okay. So from here HBr will be removed, and on the first carbon the radical will be formed, okay. So it will create a radical on this carbon. So this is your, when the radical is this radical, this is the first carbon. First carbon has a radical, and this radical is attached to only one carbon. So it is known as primary radical. It's a primary free radical. Primary free radical. Now what happens? What happens when the bromine, this Br, okay, because you know very well the symmetrical one will give the one product, okay. So that's why I have used this as a in the product, okay, to show the product. Now the second carbon, okay, either you can show this carbon or आप third carbon को भी show कर सकते हो, okay. You can show like the sharing of the hydrogen and bromine. The hydrogen will make bond with the bromine, okay, bromine free radical, and the HBr will be removed, and here the bond, here the free radical will be formed. And this free radical, this carbon free radical, now will terminate the reaction. Okay, now see, now suppose this is the second carbon. So this is again the bromine free radical. This is the bromine free radical, and this is the hydrogen. It has again a one electron. What happens over here? Again the sharing of this electron. And from here the HBr will be removed, or इसके क्या होगा, on the second carbon the radical will be formed. Carbon, the second, on the second carbon the CH, okay, radical you will show, and this carbon you will show like this, okay. So I have just, so basically there are the formation of two free radicals. Now tell me, Lubna, which type of free radical it is? What is the degree of this free radical?
Second.
Yes, very good. It's secondary. Okay, it's secondary. Why? Because the carbon, this is the second carbon pe there is a free radical, right? And this is attached further to the two groups, the CH3 and CH3 group. So this is your secondary free radical. See, this is very important. So the free radical halogenation, the reactivity is, rate of reactivity is tertiary, then secondary, then prime. Okay, see, this is very important. सबसे ज्यादा फास्ट किसमें रिएक्शन होगा, टर्शियरी में, ओके, टर्शियरी फ्री रेडिकल में, देन सेकेंडरी, देन प्राइमरी, okay, means, and this is based on the stability conditions also. So 3 degree free radical is more stable as compared to the secondary and prime, okay. So between these two products, which one is more stable? Obviously this one is more stable, this one, because two products are being formed, okay. First product is this, right, and the second product is this, okay. So this is your primary, okay, this is your primary free radical, 1 degree free radical, and this is a 2 degree free radical, okay. So what's the order of reactivity and what's the order of stability? So 3 degree free radical is more stable than the 2 degree, than 1 degree. Okay, so but wait, between these two, this is 2 degree and this is 1 degree. So obviously this one is more stable as compared to the 1 degree. Got my point?
Yes.
And Rimdha,
Yes, ma'am.
Yes, ma'am.
are you sure? If you have any doubt in any step, so you can ask. Are you sure it is clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So second step, first step was chain initiation, okay, in which the bromine just breaks into the free radical. After that, this bromine free radical, it attacks on the hydrogen of the first carbon and the second carbon. Okay, means the different hydrogen. So two different hydrogens are there in this your propane. Okay, because the CH3 and CH3 both are same, so we will take it as a only one. Okay, we will just treat it as a only one, and the bromine radical will just make bond with the HBr. Okay, this hydrogen, and the HBr will be removed. Okay, and on the first carbon, the free radical will be formed. Okay, so this is a primary free radical. Similarly, on the second carbon also, and we know that secondary free radical is more stable as compared to the primary one. Now, the third step is chain termination. If you don't terminate the chain, so this cycle will continue. Termination. Chain termination is very, very important. Now, what happens over here? The reactant, see, what was the reactant over here? So first you will take the secondary. This is more stable, right? So you will take CH3, CH, CH3, right? Here the free radical is, right? Plus, again the bromine free radical will come. Okay, this bromine, see, this bromine will attach on that position where the free radical is. So this carbon free radical came and this bromine free radical came, and they share their electrons, free electrons or free radicals with them, and they form a product. So basically आपने bromine को कहाँ पे attach करना है? Where the free radical is present. Okay, on that position where the free radical is present. So it's CH3 over here and here the bromine. So that's the first product. Second product, similarly, see this. This is your free radical, right? CH3, CH2, and on the this is your free radical plus Br. Okay, similarly, this bromine, okay, sharing of electron. You can show either using this symbol, and you will get CH3, CH2, CH2, and Br. Okay, so these are the two products you get. So that's the whole mechanism. आपको कैसे मिलता है ये दोनों products? So that's the whole mechanism. First step is chain initiation, then chain propagation. Third step is chain termination. These three steps are there in the free radical halogenation of alkane. Now it is clear now. Any doubt in any step, बच्चों?
No, ma'am.
No, ma'am.
Okay. Okay, write it down. One more point, write down in the note part. Rate of free radical halogenation depends on stability of carbon free radical. Okay, so rate of reaction depends on the stability of carbon free radical, and you know very well 3-degree carbon free radical is most stable you can say, as compared to the others, as compared to the secondary and tertiary. So that's why the rate of free radical halogenation will be very fast in 3-degree, okay, then 2-degree, then 1-degree. Okay, and rate you can also write. And yeah, one more thing, benzyl में सबसे ज़्यादा benzyl, after that allyl, after that 3-degree, then 2-degree, then 1-degree. Okay, just remember this order. The rate of free radical halogenation depends on follows these order: benzyl, then allyl, then 3-degree, 2-degree, and 1-degree. Okay, let's do some questions. Question number 1. You have to write the major product, right? Major product. And yeah, one more thing, because major product will be that which is more stable. Okay, again the major product कैसे आप decide करोगे, which is more stable. He is a tertiary, then secondary, then primary. Okay, write major products for the following. First one, Ar2 in the presence of H2. Second question, H2. Third question. Okay, please write it down. This is your homework. This is your, try this in your homework. And if there is any difficulty, I will discuss it in the next. Now see, let's suppose, I think, yeah, it's okay. So see, this is your benzylic, right? Benzylic type of arrangement. So what will be the major product? See here, this is your one carbon, okay? One carbon over here and the second carbon over here. Second carbon over here, right? Now tell me which one will be major. Which one will be major? Just remember this, second tertiary, then 2 degree, then 1 degree. See, this is your primary one. This is your primary one, right? This is your secondary one. Okay, this carbon is further attached to two groups. So this is the secondary one. So here the carbon free radical will be create and this one will be more stable. Okay, so you have to attach the bromine on this carbon. This will be your major product. This will be your major product. Got my point?
Yes, ma'am.
Okay, similarly, second one. Yes. See the second one. Which one will be the major product over here? Second and third. Okay. So this is your, these two is your homework, right? Just try to do at least try karna. Okay. If you feel any difficulty to solve these questions, so I will discuss in the next class because there's another class too. Already time is up, so we will discuss in the next class. Any doubt, anyone? Lubna, Rimda?